Hi, welcome back to Franklin Maths. This is Aaron Lewis again, and this lesson is completing the square. This lesson is ideally for students who do remote lessons. So the textbooks we're using here at Franklin are these ones. We're using the online books as well, and the calculator, which you'll see in the videos, not in this one but in later ones, will be the Casio FX CG50, which is excellent for this course. Right, so first thing we're going to do is, in complete silence, all I'm going to do is just move some quadratic equations into either side, and all you need to do is think about what the rule is. If you don't get it, that's fair enough. Okay, so I want you to look carefully at both sides there. Can you get a rough sort of rule in your mind of what does complete the square form look like? So you've got some examples on the left, and you've got some examples on the right of non-examples. Sorry, just find my pen a second. Okay, so these over here complete the square form, and these over here aren't in complete the square form. And if you can see, look, you've got a bracket plus some sort of number squared, plus or minus another number. It doesn't need to be an integer; it could be decimal. And if you look at this one here, look, there isn't. There's sort of a plus there on the end there. So that's what we're looking for, because a lot of students I find haven't seen complete the square form, or it's maybe not been covered at GCSE, but it doesn't matter. It's just recognising the form. You've got a square plus another number at the end. Okay. Right. So what you need to know when a quadratic is written in that form there. So you've got a number at the front. It could be it could be a fraction, could be negative. Doesn't really matter. And B here the same, and same with C. Just when it's written in that form, that's called complete the square form. Okay, and the examples are down here, look. Okay, and all quadratics can be written in this form. Okay, yeah, get those written down, and then you've got some really good examples, and then we're going to move forwards from there. Okay, so what I want you to do on this task is to write these down. Now you might want to divide your page into two and have completed the square form on the left, not completed the square form on the right. Or you might want to do what I'm going to do is write them out and just tick them across them. But pause the video and have a go. Okay, so let's start off with ones which definitely aren't. So this one here is not in complete the square form. Okay, there's no brackets in there for a start. It doesn't necessarily have to be brackets, and I'll talk about that in a minute. But this one here, you haven't got a square form minus another number or plus another number. Okay, the next one, which is not in complete the square form in terms of obviousness, is this one. Keep clicking that. Okay. And then let's have a look. What else have we got then, which is not in complete the square form? I think it would be this one, because if I expand this one, again, I haven't got a squared on the bracket, you just end up with x squared plus 2x. So we could write that one incomplete. We would have to turn it into complete the square form. But right now it's not. So this one is not in complete the square form. Okay. So let's do the ones now which I think are in complete the square form, which are quite obvious. So this one over here at the top here, this one is complete the square form. We've got a number at the front, which we called A on the previous slide. You've got plus or minus B here, and you've got some sort of number at the end, which is C. So this one fits in with that general form. And this one here, this one is quite obvious as well, with your A there, B there, and C there. So that one is incomplete the square form. Now I've left these two at the end here on purpose. Okay, because this one down here, you might have said that's not complete the square form, but actually it is. This one is incomplete the square form, and the reason for that, I could have written that as x plus 0 squared minus 4. We generally don't write zeros, but that one actually is incomplete the square form. And this one up here, would that be the same? have a think. And so this one here, we can apply exactly the same rules to the one we did it. So the rule we had at the bottom there, so this one could be 3 lots of x plus 0 squared minus 15. So that one actually is in completed square form. Okay, those students who have done this at secondary school, or if this is revision, hopefully that was a nice little test of knowing whether you know completed the square form or not. Okay, right, so you know what completed the square form looks like, so let's look at why it's useful. Okay, so as always, I'm going to do the one on the left. You guys can do the one on the right. I'm going to do the one on the left in complete silence. You don't need to write that down, you just need to watch. Okay, so yeah, so it is literally that easy. So all you do is take the opposite sign to what's in the brackets, which is 2, and the number on the end here gives you the y value. That is literally it. Here's yours to do. Okay, so the chances are you've probably had a quick go, or you've definitely done that mentally. You should have got a vertex of minus 7, minus 7. Okay, opposite sign, same sign. Okay, next example. Here we go. I'll do exactly the same thing in complete silence. You might already begin to see what's going to go on here. So, as expected, we take the opposite sign to what's in the brackets. I'm not fussed that it's minus 3 over 2. Don't really care what number it is. I just follow the rule. And the y value, look, keeps the sign. Here's one for you to have a go at. Pause it. Have a go. Okay, so with this one here, just to check, minus 2/7, opposite sign to what's in the brackets, and minus 9 over 2. Goes at the end there, easy peasy. Okay, same again. What do you think is going to happen? Let's test your prediction. So as expected, don't need to worry about the 5. We'll talk about that later. It's just the opposite and the same sign for the y value there. Here's yours to have a go at. Pause the video and have a go. Okay, so if you've done that, you'll have minus 3/4 and 8. Now, remember when we're talking about vertex here, the vertex of this graph, that's basically like something like that. Obviously it's not the scale, but that's what we call the vertex. So I'll add this in now. If you want to add this to your notes, this is really, really useful. This is sometimes called the vertex. Depends on what the question writer's feeling like. It could be called the minimum point in this case. If it was upside down, it'd be a maximum point. It might be called the turning point. And also you might be asked the line of symmetry, which goes like this. I remember this would be like x equals. So just watch out there. So you do get a line of symmetry. And lots of different English in here, but it's worth being able to know very quickly those different words. So you don't want to get caught out in an exam because it says turning point instead of vertex. The actual skill is actually really easy. Okay, so another example here. If you want to have a think about it beforehand, and I'll quickly jot down the answer. So in this case here, same things before, opposite signs of what's in the bracket, but this time there isn't a number here, so I can put in the plus 0 if I want to. Here's yours to have a go at. Pause the video. Okay, solution to this one then. The vertex then is going to be 3 and a 5th. Nice and easy, no drama with these questions. Okay, could you complete question 1 and question 1 only from exercise 3? See, pause the video, have a go, it'll probably take you a couple of minutes. Okay, so we want to look at really y is the coordinates of the vertex. Now, it's all to do really with this little bit here. Now, we know, for instance, that if you square anything, it's either 0 or bigger, ignoring imaginary numbers. So, if you square 0, it's 0. If you square 1, it's 1. Square 2, it's 4. Or square 2, it's 4. So you can see that if we want to get the smallest value when we square something, the smallest value you can possibly get is 0. Okay? So if we look at this bracket here, we need to make that bracket there equal to 0. And the only way that can happen is if x is equal to 2. Okay? Easy enough to do. And now if that bracket is 2, if we look at this then, so if I substitute 2 in, pen's gone ski whiff there. So if I do substitute 2 in then, so it becomes 2 minus 2 squared plus 5, which is going to give me y equals 5, and that's exactly why it gives you the vertex 2, 5, because the bracket here squared, the smallest value that could be 0, so you just need to look at which x value gives you 0, and that's literally it. So that's y. Okay, so let's have a look at how do you turn a quadratic into complete the square form, because if we can get it into complete the square form, we can work out the vertex line of symmetry and work from there. So let's have a look. Now this might be new to a lot of people. It's worth practicing quite a lot. So as usual, I'm going to do the one on the left in silence, and you just need to just watch. And there you go. So I'll run through it. So first of all, I've written the question out. The first thing I do is open a bracket. Okay? And I put an x in it. Then I halve this coefficient here. If it had been minus 4, I'd have written minus 2 in there. Then you close the bracket and you square it. And then, whatever number's here, you square and subtract it. Okay, when I did my A-levels, my teacher used to sing to me, square and subtract. But if you get that into your head and you can hear it in your mind, square and subtract, you'll never go wrong. So that's what I've done. So run back through that. Open a bracket, x goes in, plus half the coefficient of x here, close the bracket and square it, square and subtract, and the minus 9 goes on the end. My final step then is just to simplify this little bit here. Okay? Have a go at the one on the right. Okay, so let's have a look then. Same as before, we open a bracket, x goes in, we halve this coefficient here, so that's going to be plus 5, and then the square goes in the brackets, and then we square and subtract, minus 25, plus 8, still stays, and all we do then, nice and easy, is then finish off like that. Okay, well done if you got that. If you didn't get that, go back, review it, why did it go wrong, and don't let that happen next time. Okay, so I'm going to try and up the difficulty on every single example. So this is a slightly different example, and then we'll up the difficulty as we go along. So as usual, I'm going to do this in silence. Okay, so same approach for this one. I don't get too stressed out that there's a 5 or a -5 here. All I do is half it. Now you can use decimals if you wish. When I did this as a student, it was on the non-calculator paper, so I'm just trained to do fractions. So half the coefficient in front of x, square it and subtract it. It's easy to square top and bottom. Take away 9, and you can run that through a calculator. I've got no problem if you want to leave that as decimals. Here's yours to have a go at. Pause the video and have a go. Okay, if you've had a go, let's check. So we've got half the coefficient for x there, so -9/2, square the bracket, and then we're going to square and subtract, so -81/4 plus 3. Again, if you want to pick up a calculator, that's fair enough. Just be aware that if you're using decimals, if it was like 10/3, we probably wouldn't accept that in an exam. You'd have to take that as 10/3 rather than write in 3.3 recurring. So let's have a look. So 81/4 plus, that's going to be 12/4. You don't need to do all this arithmetic. I mean, it's only because I've left my calculator in my bag. Okay, so check it, make sure you got it. Okay, so the examples we've looked at so far are fairly easy. Again, armed with a calculator, there shouldn't be too much of a problem. And now we are going to up the difficulty on the next few, so just be really careful here. Okay, so with this question now, notice there's a bit of a difference now. Now I have a 2 here. It will change the technique, and it will add another step of working out. So real attention to detail on this. As usual, I'll model it in silence. Okay, so I'm just going to stop there, just so I can explain what I've done. So what I've decided to do is that this and this here will both divide by 2. And I've basically just factorised this first bit here and taken the 2 out of both terms. Left the 9. Now I know with some teachers they will take the 2 out of the 9 as well, but it will make sense for me here. And it's actually just more working out. Okay. Okay, so for this line of working out, I'm going to have to narrate after every line, I think, because this is quite a complex process to go through. So from the line above, I've only completed the square, the skills that you learned in the previous 2 examples on this little bit here. That's all I've done. If you have a look, I've opened a bracket, I've halved the -2, I've squared and subtracted. Now if you can get to that stage, brilliant, because there's only one more step. Okay, and then I'm finished. So from this line here, so all I've done is basically got rid of the square brackets. Don't worry about that, they are square brackets, they can be treated just like curly brackets if we're expanding. So I've just multiplied this bracket here by 2, and I've multiplied the -1 by 2, and obviously they've done nothing with the 9, and then I've just simplified it here. Okay, this skill here, if you can master this, that's really, really good and brilliant if you can do it. Okay, but it will require effort, and it'll be one of those you get maybe the first 2 or 3 wrong, and then you keep learning from mistakes. Here's one for you to have a go at. Pause the video and have a go. Okay, so if you have done it, you should be able to roughly mimic what I've done. So in this case here, I'm going to take a 3 out of the first two terms. It's actually quite similar, isn't it, to the other one? Oops, square bracket there. Plus 13. And as before now, if I was teaching you in a classroom, I would use a slightly different colour, I think, for this bit inside the square brackets. But notice how I write this out. Notice that I sort of set it up, really, and then begin to work here. I don't want to get bogged down by forgetting about this bit here, so that's just a quirk that I have. I tend to just, anything I'm not going to use in this next line, I just tend to write it down here. So I'm going to complete the square on this little bit here, so it's going to be x minus 1, just like the previous example, squared, square and subtract. Be careful, 1 squared is still 1. Lots of students, particularly in the panic of an exam, might put 2. So last thing there is just to get rid of the square brackets. And then just to finish off then, last line. Plus 10. And if you think about it now, I could now ask you what's the turning point, what's the vertex of this graph here. So I could ask you an exam question, can it find the vertex of 3x squared minus 6x plus 13? And you can now do it using the 2 skills you've obtained. Right, last couple of examples, and this is where the work does sort of ramp up a little bit. So if you've got a calculator, use it. If you want to stick using fractions, that's fair enough. Again, I'll do this. I'll narrate this line by line. Okay, so let's have a look. I haven't changed my method. I've stuck to what I learned from the previous example. So I've taken a 2 out of the first 2 terms. Now, if you don't like me writing 11 over 2, feel free to write that as 5.5. Okay? Stuck to exactly what I know. So I'm going to do what I did on the previous slide as well. Okay, so this line here, please don't get bogged down with any arithmetic. Okay, in the exam, for all of your exams, you're allowed a calculator, so I'm happy for you to use it. But also just be aware that 11 squared there is 121, 4 squared is 16. Square and subtract, same as before. Don't get stressed out by the numbers. Last step then is I'm going to sort of get rid of that 2. Not get rid of it, but multiply out the square brackets. Okay, so with this line here, multiplying by 2, if you multiply a fraction by 2, you effectively half the denominator, you're sharing it into less pieces. Again, if you've got a calculator, you can just press the FD or SD button, depending on which calculator you're using it, and quickly change between them and not get too worried about it. And that's finished. So the only thing that's possibly going to be a bit of a stumbling block here is obviously this first step here. If that bit's alright, it normally goes okay with students. And the numbers here, as I keep saying, just don't get bogged down with arithmetic. Here's one for you to have a go at. It's completely risk-free. It's your chance to see what you can do. Pause the video and have a go. I'm not sure what's happened there, so I'll go underneath. So with this one here, I'm going to take a 3 out the first 2 terms again. So I'm going to have x squared. Well, what happens if you effectively divide 10 by 3? We'll end up with minus 10 thirds. Not the nicest number on this one, but I can't stop that happening and it might appear in your exam. So, as before, we're going to complete the square on the inside the square bracket there. So you're going to half it. So to half it then, we're going to sort of double this denominator, or we can half the numerator. And you could pick up your calculator, write 10/3 and divide it by 2. It's easy enough to do. And what a silly mistake there. Russian. So look, even I make mistakes. Okay, square and subtract. Minus 25 over 9. Shut the square bracket, put the plus 3 in the end. Now we're going to try and get rid of the square brackets by just multiplying out. Oh, got to the bottom of the board there. Multiply that by 3, so divide the denominator by 3 plus 3. Final answer then. Should have already used my calculator. A bit of a jump there because I had a bit of a technology problem there. Where's my mouse gone? There it is. Back to pointer options. Apologies for that. Squared there. So minus 25 over 3 plus 9 over 3, which is going to be 3 x minus 5/3 all squared, which is going to be minus 16 over 3. Well done if you got that. But this is sort of as difficult as it gets. Now obviously I could have put like a half in there or something like that to make it more difficult. But it's exactly the same approach. It's more about the arithmetic than anything else. Well done if you got that. If you didn't, you need to look back and try and improve it. What I'm going to do now is I'm just going to show you how you use a negative. Okay, this should be a little bit quicker, so I will narrate over this because you should have gained quite a bit of knowledge on this now. So, as before, I'm going to take out the minus 2. So I end up with x squared, x squared. What happens if you take a minus 2 out? Well, that means that sign would change as well. Because if you multiply it out, minus multiplied by minus will give you a plus. So if you took a 2 out of 7, you effectively divide it by 2. And then if you take a minus out of a plus, but if you divide a plus by a minus, you end up with another minus. So that's how that works. I mean, feel free to expand it and double check. So same as before. Because we're concentrating on that square bracket, I'm going to write it like that. And inside here, half it, square and subtract. Should have chosen some nicer numbers for my examples, but if I'm showing you, I mean, they're sort of as difficult as it gets, I don't think that's going to necessarily be a bad thing. Last step then, well, second to last step really, is to get rid of these square brackets. So multiply that 2 by that bracket and 2 by that fraction there. So we're going to end up with minus 2x minus 7 over 4 squared. Again, feel free to pick up a calculator if you're unsure, but multiplying this by minus 2 will change the sign. Just be careful with that. That's a common error. And because we're doubling this fraction, we're going to half the denominator. Okay, so final step then is just to jot the answer down. That's 40 over 8, isn't it? So it should end up as 9 over 8. Okay, and that's it done. I say that's probably as difficult as it gets with the minus. Even with a minus, even if you just had a minus, you'd do exactly the same thing. So if you just had, say, minus x squared plus 4x and you have to complete the square, you can just take a minus out, use square brackets, x squared minus 4. Complete the square on just those square brackets there, and it's just the same. So just treat the minus as effectively as minus 1. Right, here's yours to have a go at. Pause the video and have a go. Right, here we go. So, this will seem quite long and laborious, but it is a multi-step task. And with A-level maths, you have to be able to cope with lots and lots of different skills all at different times and being able to hold a lot of processes. So, let's have a look. So I need to change the sign on that one, no silly errors here. 14 over 5. X, again, some horrible numbers here, but I'm sure we can cope. Minus 5. Complete the square on the bit in the brackets, so half that there, so that's going to be, I could write that as 14 over 10, but it makes sense to just write that as 7 over 5. Square and subtract. Shut the square bracket. Add the 3. Now we're going to multiply the bracket first, so minus 5 x plus 7 over 5 squared. So if we multiply this by minus 5, that's going to go to a plus, and it's going to then become 49 over 5, and you might want to think why that would be. 5 times 1 over 25 would be a fifth effectively. Again, just use the calculator if it's going to stress you out too much, because really here it's the focus of learning completing the square rather than can you add and subtract and multiply fractions. If you can, great. If not, don't worry about it. Okay, so what have we got here then? That's 15 over 5, which I think is going to be 64 over 5. Okay, if you got that, great. If you didn't, again, just try and correct it. Okay, so pause the video, complete question 2 from exercise 3C. I will say though, if you do need more practice, you can literally just make your own question. And you can sit and practice, and you could expand it back out if you want to check. Okay, so how can we use completed the square form? Okay, so let's have a look at this question here. So we've got a graph drawn, we've got the y-intercept, and we've got the vertex. Okay, so we know that if you complete the square, you get the vertex. Okay, so initially, when I've worked with students in the past, they've gone, oh, this is easy peasy, it's just y equals, so it's the opposite to what's in the bracket, so it's x minus 2. Think about that skill that we did many slides ago now. Minus 5, thank you very much, give me the marks, but it wouldn't be right in this case. Okay, and I'll show you why. So the first thing we have to do is write down this. Now notice it's that A there. The A stretches the graph, so it won't affect the vertex, but it will affect the y-intercept here, which is why we just need to be careful. So I am going to write the A in this time, and then now I can use the vertex. So it's be x minus 2 squared minus 5. And the question is then, how do you get A? Well, all you do is just choose this coordinate here. So we know that at this point here, the y-intercept, we know that x is equal to 0 and y is equal to 3. And we're just going to substitute those in here. So y we said was 3. We don't know what A is, but we'll be able to find it. We know that x was 0. So it just sort of disappears. Minus 5. And then this just needs solving. Just being really, really careful. So minus 2 squared is plus 4. So that's 4a. Minus 5 goes there. And it's now just a nice, easy linear equation to solve. So add 5 to both sides. Divide each side by 2. And a is then 2. So my final answer then is this, but I need a 2 at the front. Just watch out for those questions there. So that is the answer there. Easy enough to do. So the process was substituting the vertex into complete square form. Don't forget this multiply here because that will stretch the graph. And then I've just worked it out by knowing one of the points. Here's yours to have a go at. Okay, so let's do this one a little bit quicker than we did the previous one. So the first thing I'm going to do is write this as y equals a. Use the vertex, or the turning point, or minimum point in this case. So x minus 2 minus 10. And I just need to figure out a. So we know that when x is 0, we know that y is 2. So 2 goes in. A we don't know. We know that x is 0, so it's minus 2 squared again. Minus 10, and I'm just going to do some maths. If you were stuck in the exam on this line, just look at it and go, okay, is there any maths I can do? So minus 2 squared is 4, so it's 4a minus 10. Add 10 to both sides, so 12 equals 4a. And therefore, a would be equal to 3. So my final answer is y. Oh, just lost my pen there. Y equals 3 lots of x minus 2 squared minus 10. Now, if you have got one of the fancy calculators and you have already bought one, you can draw these graphs in and verify all this is correct. Okay, could you complete question 3 of exercise 3C using that slide you've seen? Pause the video and have a go. Okay, so with this section here, I'm just going to show you how you could use completely the square form. Okay, and why is it useful? Now, questions like this, you might have seen in your GCSE exam before. So, a lot of the time, it will say, solve this equation and write your answer, in so many decimal places, or use your calculator. So normally students would use the quadratic formula, but actually, in this case, it might be easier just to use completed the square form. Now, the quadratic formula does come from completed the square form. If you want to ask your teacher in lesson to run through that for you, I'm sure they will. Or you can just look at the proof online, it doesn't really matter. So, now quadratic can only really be solved if it's equal to 0. It's much easier to do if it's equal to 0. Let's make it equal to 0. Minus 1 equals 0. Okay, so I could use a quadratic formula, but we could also just complete the square. So I'm going to do exactly what we did earlier. So take the 2 out the first two terms. Square bracket there, Aaron. Minus 1 equals 0. So complete the square inside of the square and a half square bracket there. X minus 2 squared minus 4 minus 1 equals 0. So I'm going to end up with, I'll do this next bit in one line. X minus 2 squared. That'd be minus 8 there, minus another 1 is minus 9 equals 0. So what I'm going to do now, to solve this, first thing I'm going to do is add 9 to both sides. A lot of students now will get a little bit excited and start, want to square root both sides, but if you did square root both sides, you have to square root this 2 as well. So it makes sense to divide by 2 first. That's 9 over 2. I'm just going to go up here on the side over here. I'm running out of space. I should have been an artist. Right, from there then, we're going to square root both sides. So it becomes x minus 2. We don't have to keep the bracket. Now obviously when you square root, you do get a plus and minus. Square root of 9 over 2. X minus 2. Now this bit here can be cleaned up a little bit. So the square root of 9 is 3. And the square root of 2 is the square root of 2 because it's a third. And the last step then is x is equal to 2 plus or minus 3 over root 2, and I'm done. So all I can do now is use complete the square form to actually solve a quadratic. You might think that's slower than using the quadratic formula, but it doesn't really matter. It's quite a useful little skill to be able to learn and be able to do. Okay, so complete question 4 onwards from exercise 3C. Upload your work to Google Classroom before the deadline. Any questions, ask your teachers. Thank you very much for watching.